All right, welcome back. So looking at your answer for C, I did this one using an input-output approach. So I started with x, and then the first thing that happens to x is not the multiplication by 2, but it's the exponent of 2, so I square it. Then I multiply by 2 and add 3, and that gives me y. So in reverse, I'm going to subtract 3 first. Let me just fix my mistake down here. Subtract 3, and then divide by 2, and then take the square root. So when you take the square root, remember to do your plus or minus of each side, and I'll show you why that's going to be important, because let's take a look at the graphs of both the original and the inverse. So on Desmos here, okay, so again, here's a graph of the original function, 2x squared plus 3. And you'll notice here when I get my equation of the inverse, it's y equals plus or minus the square root of x minus 3 all over 2, which really means you have two different answers, right? Plus the square root of x minus 3 over 2 and negative square root of x minus 3 over 2. So there's two different graphs there that you need to graph. So putting them on here, the reason you need both, so you'll see now once I put both pieces there of the inverse on there, it actually does resemble the original function. You can see it's a reflection across the line y equals x. If I forget to do the plus or minus, I'm going to be missing a piece. And all of a sudden I have the inverse of this parabola being now half a sideways parabola. So that plus or minus has to be there. Okay, so now looking at the next one here, another little bit of an anomaly happens. So this one I did using a more algebraic approach. I interchanged x and y and then solved for y. So you'll see as I went through this here, I went through some algebra. So I subtracted 8 from both sides of the equation. Okay, and then I multiplied by 7. So I multiplied by 7 here. Those cancel, and I got 7 times bracket x minus 8, which I simplified into 7x minus 56. At this point, then I squared both sides of the equation to get rid of the square root. So I got 7x minus 56 all squared equals y minus 3, which I then solved for y by adding 3 to both sides. Now let's take a look at both the graphs of both the original and its inverse and see what kind of weird stuff happens here. Okay, so here's a graph of my original, and it kind of looks like, again, the top half of a sideways parabola. But you'll see if I put in the line y equals x, look what happens when I plot the inverse. All of a sudden it's different, right? Because the original function was half a sideways parabola. The inverse, looking at the equation at least, is a full parabola. So there's a bit of a disconnect here. And the problem is we only had one piece of the original function to graph. It wasn't plus or minus 1 over 7 square root x minus 3 play, just the positive one. So what we need for our inverse, instead of just half of a parabola, instead of the full parabola, we just need half the parabola. So how do we do that? Well, let's go back to look at the function here. And let's take a look at the original equation here. Okay, and more specifically, I want you to take a look at the domain and range of it. So looking at this, we know that we can't take the square root of a negative number, right? So we know that for the domain, x minus 3 has to be greater than or equal to 0, which leads to us saying that x has to be greater than or equal to 3. Okay, now think what domain and range might mean in terms of the inverse. So we already saw earlier that the x and y values from a function to its inverse are interchanged. So if this is the domain of the original function, this has to be the range of the inverse. So for this guy, the range should be, instead of x being greater than or equal to 3, y should be greater than or equal to 3. Let's see if that actually holds true on the graph. Okay, so right here we can see x is greater than or equal to 3. And on the inverse you can see y is greater than or equal to 3. But that's not really our problem here. What we were trying to look at is how we can only get half a parabola here. Well, let's take a look at the range of this guy. So the range of this, you can see y has got to be greater than or equal to 8, which means on the original function, that would mean that x has to be greater than or equal to 8. So if we add a domain restriction on here, that says x has to be greater than or equal to 8, that will give us the exact half a parabola we need, and all of a sudden you can see it's a mirror image across the line y equals x. Okay, so we're going to look more at that when we look at how to transform domain and range, and more specifically how to get domain and range of these types of functions out without using a graph. But it's something to be careful of. Right now, when you take the inverse of a square root function, you wind up with a parabola as the inverse, as the graph of the inverse. You have to restrict the domain somehow of the inverse in order to get it to work out. But we'll see more of that later on. Okay, so let's move on and try something else now. And we've already seen an example. In fact, it was this one right here about how even if the original is a function like this one actually is, the inverse might not be a function. So we saw back on an earlier slide that the inverse of this one, it happens to be this. And you can see that while the inverse is a function, while the original is a function, the inverse is not, because when x equals 12, you have two different y values. Okay, so let's take a look at a few other ones and see what we can get. So here, looking at y equals negative 2 over 3x minus 7, that's a line, so that's clearly going to be a function. Okay, and if you think about what the inverse is going to be, without even having to think about what the actual equation would be, well, think graphically. You have a line, you're reflecting across the line y equals x. The inverse is also going to be a line, so the inverse should also be a function. Okay, now let's take a look at C. Well, okay, so C is a parabola, and we know from a parabola, well actually, sorry, this one's opening down, that this is definitely going to be a function. Well, the inverse of a parabola is going to be a sideways parabola on the graph, so the inverse is not going to be a function. Now, so the question is, how can we do this in general? Because now we look at something like D, where we don't have the equation. What's the inverse going to look like? Well, let's go back to the parabola example. Okay, so there's the graph of the original in black, and there's a graph of the inverse in red, and you can clearly see that the inverse is not a function. Well, so let's think about how we might be able to figure this out without again knowing the equation of the inverse. So remember, on the original function, for it to be an inverse, we're looking, for it to be a function, what we need is every x value to produce a unique y value, okay, which is clearly the case in this black graph right here, and clearly not the case on the inverse. So remember that since the x and y values are interchanged between a function and its inverse, if we're trying to look quickly from the original graph to see if it's going to be a function, remember that, again, for it to be a function, every x value has to produce a unique y. What we need is the opposite to be occurring for the inverse to be a function as well. So what we would need is each y value to produce a unique x value, which you can see happens, doesn't happen most places, right? Look at where y equals 2, we have two unique y values, which means that when x equals 2 on the inverse, we have two y values. So another way of thinking about it is to use, well, we had what we called the vertical line test to try and see if the original was a function. Well, now we can do a horizontal line test to see if the inverse is going to be a function without actually having to graph it. So there's a horizontal line. You can see that if I move it up here, all of a sudden, oh, there's going to be a problem. I cross the graph more than once. So even though the original is a function here, the inverse will not be a function, because what I have here is a y value with more than one x value. So on the inverse, it'll become an x value with more than one y value. So the inverse is not a function here. And you can do something called the horizontal line test to find out if the inverse is a function without actually having to find the equation and graph it. Okay, a couple other things to look at here. So now let's take a look at a function here. It's a parabola in vertex form. So I want us to work with function notation again. So the first thing I want you to do is figure out what f of 4 is. Then I want you to think about how you could figure out f inverse at 6. So remember the notation here. F at 4 means that x is equal to 4 on the original function. What's y? F inverse at 6 would mean x equals 6 on the inverse. Okay, so I want you to think about how you go about doing both of these and actually give them a try and push play and ready to go through them together. Okay, so you can quickly take a look at your answer for A here. So remember, f at 4 means you replace the x value with 4 and figure out what y is. So when you put 4 in, you get 4 minus 7 all squared in here, which is negative 3 squared, which is 9. You multiply that by negative 5 to get negative 45. Add 10, you get negative 35. Now, as for B, there's a couple ways of going about this. Now, what some of you might have done is you might have said, okay, if x equals 6 on the inverse, I'm going to find the inverse, the equation of the inverse, and then sub in x equals 6. That absolutely will work, but it is a lot of work. What might be a little bit faster, remember, again, since the x values and y values from a function to its inverse are interchanged, if this is saying that the x value is 6 on the inverse, if this is the same thing as saying that the y value is 6 on the original function. So this is exact. So whenever it says find f inverse at 6, this is the exact same thing as asking you to solve f of x equals 6, which again means that y is equal to 6. So So this is a much easier problem to solve because you don't actually have to actually find the equation of the inverse first. So if I do that, I'm going to have 6 equals then negative 5 bracket x minus 7 all squared plus 10. And then I just need to simply rearrange the equation and solve for x. So subtract 10 from both sides. And you can see the rest here is just going through algebra. So I end up with two possible answers. The positive root of 4 over 5 plus 7, and the negative root of 4 over 5 plus 7. Okay, you would get the exact same thing if you found the inverse first and plugged in x equals 6, but this saved me the trouble of actually having to find the inverse. Okay, so one thing to note here, I technically should not have used function notation here because the inverse of this is not a function, it's a sideways parabola. But again, just in terms of getting used to what this means, this does mean x equals 6 on the inverse. Just keep that in mind that I shouldn't have used function notation here. Okay, so some other things to note here for domain and range of the inverse. Again, you could find the inverse and find the domain and range from there. But one of the things we already talked about is, again, x and y values from a function to its inverse are interchanged, which should mean that the range of a relation is the same as the domain of the inverse and vice versa. So you shouldn't need to actually find the equation of the inverse here unless you really don't know how to find the domain and range of your original function. But looking at our original function here, we already know a lot about this. Okay, so I already know just by looking at this that my vertex is at 7, 10, and that I open down. Okay, so I can make a quick little sketch of this. So 7, 10 for my vertex in the top right quadrant. I open down. It's a very bad drawing, but I can just get a general sketch here. So that means that for my original function, my domain is going to be x an element of the real numbers. And my range is going to be any y value that is less than or equal to my maximum, which in this case is 10. Okay, so what does that mean? Well, it now means that for my inverse, the domain of my function should be the range of my inverse. So my range will be y is an element of the real numbers. Okay, and my domain will be x is less than or equal to 10. So again, never needed to find the equation of the inverse here. Just use the fact that I knew the domain and range of my original function to find the domain and range of the inverse. Okay, so a couple other things here. So just to sort of summarize everything we've done about inverse, just so you have them all the information in one convenient place. So the idea is it undoes the steps of a relation or a function to try and create a new equation. Algebraically, you're interchanging x and y to solve for y, so you can do that again using that method or using an input-output diagram. Both methods will work. Okay, graphically, it's a reflection in the line y equals x. Okay, and if a point AB is an element of f, so i.e. if you have a point that's on a function, then interchanging the x and y, BA will be a point on the inverse. Okay, and domain of a function is the range of the inverse, and vice versa, so on and so forth. Okay, so last but not least, two little questions to do here. So this one just wants us to find f inverse at 3, which remember means the x value on the inverse is 3, which is the same thing as the y value on the original function f of x being equal to 3. So I'm going to want you to try and solve these on your own first. Okay, and once you have them solved, push play and we'll go through the answers together, and that'll be it for the lesson. Okay, so again, I set y equal to 3 in the original function, or f of x equals to 3, and you can follow the algebra steps here to eventually solve for x. I had to work with some fractions here. Remember, find a common denominator here. I'll let you walk through the steps. If you have any questions, just come see me, but hopefully you get an answer of x equals 9 over 80. And last but not least, for b, again, if y equals 3 on the original function, I trace that out to here, and I see on the graph x is equal to 1, so f inverse of 3 equals 1. Okay, your homework.